All right, raise your hand if you're done with number 5. Raise your hand if you're done with 3, 4, and 5. Looking at the answers here. I have the answers. I have the answers. All right, so let's do this. So we're going to go right to the dot cam. We're going to right to the dot cam. I'm going to show you I wanted to show you my face first before it disappears for the rest of class. Okay, so here are 3 and 4. Here's 3 and 4. Take a minute to look at those. Finish up 5 and 6 if you have not yet. And let's look at 5 and 6. By the way, I'm going to publish this answer key, but it's got the synthetic division stuff on it too because it was all one file. So I'm going to wait to do that. So here's 5 and 6. What do we need for number 5? What's in blue there? What do we need for number 5? In the divisor. No, in the divisor, in blue. Need, oh yeah, my handwriting's horrible. Okay, what's going on in the divisor there that you should have had? What did the divisor need? You have x squared plus 3. You had x squared plus 3. Yeah, you needed the 0x. The 0x is a placeholder. You needed it in number 6 as well, basically, for the 0 there, because you needed the 0x squared in that first, and then the 0x there. Shouldn't have affected too much, that one. But yeah, you needed the 0x squared for number 6 in the dividend. You needed the placeholder 0x in the divisor here. Yeah, lots of stuff here. I'm not surprised it took people a while. Thank you, Rhea, for coming in with everything already. I'm not surprised that it took a while for you guys to do these. Hopefully you didn't make any mistakes. Hopefully you didn't make too many, if there is 1 or 2 there. Yeah, one wrong move. You guys have seen it. One wrong move, and then all this gets messed up. So you have to be very patient. You have to have very strong algebra skills. You got to be very resourceful. All those intangible things that make you a successful student. You have to be conscientious. All that stuff to do well on these. Okay, like I said, I'm going to publish this answer key later on, but there it was. Now, let's get to synthetic division. So this should be the next page for you guys. Synthetic division. All right. Well, I need to answer a really, really important question first. Okay, when am I going to use this in real life, Mr. Haran? Because this is the type of stuff that really, really rocks kids. They do this, and now we're going to do a synthetic version of it. Okay, well, a couple things. First of all, when you guys play like a sport or you play your instrument, you don't like play a scale directly in most pieces, right? Like you use the notes of a scale, but you don't play the scale like right in a row. Because that'd be very uncreative for the composers of the piece. Likewise, you don't like do push-ups in the middle of like a tennis match, even on a basketball court or football field where like you are pushing guys, like your elbow and hands are at different angles and stuff like that. So you're using the same muscles, but not the same way. You're never going to lay down and have a barbell that you just push. So we're doing these exercises to increase your intelligence, basically. It's helping you make connections. It's helping you be patient with things. It's helping you to order things in the correct way. Okay. When you're part of a gaming company and try to recall memorable events on a graph, that's what, touche, you got me there. But yes, that was applicable. I'll defend that on Monday. We'll look at that again very briefly, hopefully this week. What else did I want to say about this? Oh, this is really important. In fact, I want to show my face to you guys when I say this. This is a line that I want a lot of teachers to use, because it's important, I think, for my generation and then the generations. Oh my goodness, there's 2 generations below me when you really think about it. This is important. You guys are going to have some jobs that only, especially like in college and stuff, when you have jobs in the summer and everything, and that happens in high school as well. There's going to be some jobs you're just not there. Maybe a job you wanted to be in for 5-6 years. Maybe the company gets bought out. Maybe the company goes out of business. You might be in a job for only a year when you intended to be in there longer, or like a summer job where you intend to only be there for the summer, like 8 to 10 weeks. You still have to do the job. You still have to do the job. And where am I going with this? Your life is school. When students ask, when am I going to use this in life? I'm like, tomorrow, on the test next week, on the SAT and on ACT that you're going to take, in algebra, I almost said algebra 3, in pre-calculus next year. That's when you're going to use this. You're going to use this in school. School is your job. School is your life. You spend most of your waking hours in school or school-related activities. So whatever the boss, in this case it's me, whatever the boss wants you to do, you have to do. Or else you're not going to get what you want, whether it's the paycheck, whether it's the satisfaction of maybe working in a nonprofit with pay isn't as great, or you're going to get the grade in this case for this. And the grade has nothing to do with whether I like you or not, even though I like all of you. It has nothing to do with that. The grade is the grade. It's math is math. Okay, so you're going to use it in life tomorrow and today. This is what your life is. Your life is being a student, and not everything you do is going to have. Going to be applicable to the next job. Like when I was a consultant, I found out I got Teach for America November 1st. I had to still do consulting until May. Okay, I knew where I was going to be in Dallas 7 months from now, but I still had to do my work. I couldn't just not do anything for 7 months. I still had to do the consulting job, which has little or nothing to do with what I do as a teacher, and I knew that. I think you're going to like this better than you liked yesterday and the start of class today. How about that? Okay. I think you guys are going to like this a lot because synthetic division is actually a shortcut. Synthetic division is a shortcut. So, you guys can read these directions, but I want you to read them maybe after I do the problem. So I don't want you guys to try this. We do explorations in here, but something like synthetic division I think needs to be directly taught. I don't want you guys to have any misconceptions about this. I want you guys to know exactly what to do. So you see this x minus 1 here. All right, you see this x minus 1. Well, if you set x minus 1 equal to 0, yikes. If you set x minus 1 equal to 0, you get 1. You get 1. So I want you to put a 1 right here, and I want you to do that to it, okay? It's not a full box. I probably shouldn't have even touched the line here. It's not a full box. I just want you to make that half square right around the number 1 here. I know you guys are swift with factoring and everything, and you can probably see that you would break up this, which is awesome. But we're not going to do that just yet. We're not going to do it just yet. I want you to put the coefficients, okay, the A, B, C coefficients of this quadratic, okay. The A coefficient is 1. The B coefficient is a positive 5, so you can just put that there. And the C coefficient is negative 6. I'm going to space that out. Leave some space, okay, leave like a ½ inch of space here to write. Okay, and watch what I'm going to do. I'm going to drop down the 1 right here. I'm going to drop down the 1. I'm going to do 1 times 1. Okay, so I'm going to take this 1. I'm going to do 1 times 1. And that's going to be 1, of course. And I'm going to put the answer right here. All right, just do what I'm doing. Listen to what I'm saying. It's on recording. I'm going to go over this again anyway. You're not going to subtract. You're going to add. This is why I wanted to teach this. You're going to add 5 and 1 to make 6. You're then going to take the 6 and you're going to multiply by 1. So you're going to do 6 times 1, which is 6, and you're going to add the negative 6 and 6 together and get 0. Okay, make sure you have all that. This 0 that you have here is actually your remainder. Okay, so if we have a 0 here as the remainder, what does that say about x minus 1? When you have a 0 as a remainder, what does it say about what you're dividing by? Excellent. Excellent. It is a factor. So x minus 1 is a factor because we have a remainder of 0. Now, it's a quadratic, so there'll be 2 binomial factors. What's the other factor going to be? You guys could have probably figured it out just like looking at it. The other factor is going to be 1x plus 6. Or in this case, just x plus 6. All right, so if you had done long division, that's what you would have gotten, or if you just did factoring. Yeah, it's the second page of yesterday's sheet. You're going to love this. You guys are going to love this. You're going to love this. And watch, you'll really see the magic on number 8. Okay, one thing to note before you guys try number 8, which you're going to. Long division can always be used. You can always use long division. And I'm going to give you a way that only synthetic division can be used. Okay, you can always use long division no matter what. Now, I'm going to take this blue pen here, and I'm going to do this problem again, but watch this. I'm just going to guide you through it. Okay. The first step is this drop right here. Okay, step 1 is you drop the 1 down. Okay, so once you have the x minus 1 equals 0, once you have the 1 here, and then you have the 1, 5, and negative 6 as the coefficients, you're going to drop the 1 down. The second step is right here on this arrow. Step 2 is multiply. Okay, once you drop the 1 down, you multiply it by whatever in here. In this case, it's a 1. And then you're going to put your answer right here. All right, rewatch this video if you need to. I wouldn't be writing all over your thing, although it's not that big of a deal. No, so I meant this. I'm going to give you the parameters that only synthetic division can work. That's what I meant to say. You can use long division all the time. Synthetic division only works in certain cases. I'll tell you when very soon. Okay. And then 4, you're going to add. I'm going to put this in capital letters, add. This is where students make mistakes. They think because it's division, you're subtracting. Because they're used to the long division and everything, you're actually going to add. You're actually going to add. Okay, 5, you're going to take your sum. And then step 6, we're going to multiply. And notice where I'm going to do this. I'm going to put step 6 up here. Okay, you're multiplying on this arrow again. You're multiplying the 6, even though it's step 6. 6 times 1, which makes 6. Okay, so 7 is going to be your answer again. There's your answer from here. And then once again, you add. I can't emphasize that enough. Step 8, you add again. And then you find your remainder. If you want to call that step 9, that's fine. Get your remainder. And you'll see if the original divisor is a factor of this dividend. And our quotient is x plus 6. There's no remainder. Okay. Now, I want you to give number 8 a try. Okay, give number 8 a try. Set it up. Set it up. What do we need here? What kind of function is this? What kind of dividend is this? What kind of dividend is this? What kind of dividend is that? What kind of function would that be if it were y equals? It's a cubic, yeah. So what are we going to need? We have an x cubed. We have an x to the first power. What do we need? What do we need? Yeah, what do we got to put in front of that? Or what's going to be a coefficient going across? Yeah, a 0 coefficient for the x squared. Okay. Set that up. Raise your hand when you're done with number 8. Okay. Now, before we get into a turn and talk, because I want to make sure this is correct, I hate to steal the students with their hands raised or about to raise their hands thunder, but I'm going to have to take the thunder here because, or steal your thunder because I want to make sure that you guys get this correct. All right. So there's a little bit of a magic. You should not have been doing this in Algebra 1 at all. You should not have been doing this in Algebra 1 at all. So we're going to take this x plus 3 equaling 0, and we're going to have negative 3. All right, just so you know where that comes from. You guys can jump. I bet you guys jumped right to negative 3 and you put the half square around it. That's fine. That's fine. I'm just showing you where that comes from. And then we had a 1 in front of the x cubed. What was missing here? You guys told us a 0x squared. So we're going to have a 0. We have a 1 in front of the x to the first power. And then we have a positive 30 as the constant at the end. Yep, I'm going to show you now. This is where I'm going to just kind of do the magic trick. As opposed to telling you how the magic trick works, I'm going to just do the magic trick. So leave some space. I'm going to have this here. You drop the 1 down. You drop the 1 down. And you're going to have 1 times negative 3, which is negative 3. You add the 0 and negative 3, which is negative 3. You do negative 3 times negative 3. That's a positive 9. You add this together to get 10. And you do 10 times negative 3. And you get negative 30. You add this together and you get 0. And since this is the last thing that we have to add together, we have a remainder of 0. We have 0 as the remainder. Now, I have a question for you. What if we have a 0 as a remainder, what does that say about x plus 3? What does that say about x plus 3 for x cubed plus x plus 30? What does it say about x plus 3? Yeah, x plus 3 is going to be a factor because there's no remainder. Now, when you do x into x cubed, when you do x into x cubed, how many times does x go into x cubed? Let's pretend we're doing long division. How many times does x go into x cubed? How many times does x go into x cubed? Good. So we're going to have a quadratic. If we were to do long division, we'd have a quadratic. And here's your quadratic. Ready for the magic? Here's the rabbit coming out of the hat. We're going to have 1x squared minus 3x plus 10. If you did long division on these guys, that's what you would have come out with. Much easier, huh? Much less writing. Okay, it works only because we're doing a linear into a polynomial. And we're doing a linear with a coefficient of 1. Okay? We're doing a linear with a coefficient of 1. If this was 2x plus 3, what would we have to do? Sorry, guys. If this was 2x plus 3 instead of x plus 3, what would we have to do? Take a look at the note. What would we have to do if that was 2x plus 3 instead of 1x plus 3? Nope. Nope, that's not going to work. Nope, not going to work. Nope, not going to work. Take a look at the note right above number 7 and 8. And we'd have to do what instead, Rhea? She's right. What do we have to do instead? If that was even 2x plus 3, long division. What if this was x squared plus 3? What would we have to do? If this was x squared plus 3, what would we have to do? Long division. Exactly. You have to do long division. So the synthetic division only works, okay, when you have an x to the first power. You have an x to the first power, and it must be x plus or minus c. Okay, it doesn't matter if it's plus or minus there. It's got to be 1x, okay? And this is big. Write this down. Cannot use when coefficient doesn't equal 1, okay? So if this is a half in front of an x, a 2 in front of an x, a 12 in front of the x, it's got to be 1x plus or minus c, okay? It doesn't matter if it's a minus 1 or a plus 3, whatever. It can only be that. Yes, but McKinley, that's only working because you have 4x minus 4 there. You have 2, 4. Yeah, if that was an x squared minus 4, you can't take a 2 out. If that wasn't 2x squared, or if those weren't 4s, you can't do that. Yeah. It doesn't work. It's a specific shortcut. It's a specific shortcut. Let me get an analogy for you as you guys try. Let me see what you guys try in prior years. Okay, I have some of these problems on the do now. Why don't you guys do number 10? You guys can do number 10 before the end of class. Why don't you give 10 a try? Give 10 a try. Go. Yes, I will. Let's just get one more in. I want you guys to functionally be able to do this because I do want to lecture about that. I just want to get this in the next 5 minutes. Okay, raise your hand when you're done with number 10. Why don't you guys take a minute to turn and talk? Then I'll take the last 2 minutes of class. Go. Not the dividend. Not the dividend. Okay, yeah, let's do this. Eyes on the screen here. Okay, your coefficients are 1, -2, and -48. You're going to drop the 1 down. 1 times -5 is -5. You add negative to get -7. -7 times -5 is a +35. So you have -13. Okay, we're out of numbers, so we have a remainder here. We have a remainder. So we have, well, x going into x squared is going to be 1x minus 7. And then we're going to have a remainder of -13, or we could write it as -13 over x plus 5. Okay, be careful with the sign switching here, guys. All right, over x plus 5, and of course this is plus -13 over x plus 5. So you could have x minus 7, remainder 13. You could have x minus 7 minus 13 over x plus 5. Okay, all three of these are correct. All three of those are correct. All right. Do you guys like synthetic division? Do you guys like synthetic division? Yes or no? Do you guys like synthetic division? Yes or no? Everybody in, one more. One more. Take a stand. Take a stand. Okay. Everybody loves it. Good. Clean sweep. Unanimous. See you guys tomorrow.